Hello, I now present to you the marvelous Klein-Urania typewriter. This particular example was produced in 1936 by Clemens Müller Aktiengesellschaft of Dresden. Clemens Müller started out in 1909 with the production of the Urania No. 1. In this case, I have a wonderful 1911 example which I obtained from Spain. In this case, it so happens that the 4-digit serial number is the exact same as the example that was shown in Will Davis's European typewriter project. That means that this example is from the Tilman Elster collection. So that was a wonderful bit of serendipity, considering that this machine was originally advertised as a number 3, and in this case, another thing that you can do to identify it as number 1 is the fact that it has a typewriter key instead of a right shift key. Given that, Clemens Müller continued producing standard typewriters up to 1954 with the Model 9A. Now, it was in 1912 that they started producing portable typewriters, namely the Perkeo, which was a 3-bank portable like the Corona No. 3, which was produced from 1912 to 1933. Then, in 1925, they produced the Piccola, which, like this Torpedo 12, which was first produced in 1925, and this Merz, first produced in 1926, were among the first German 4-bank portables made in response to the new 4-bank portables being produced in the United States. Now, firstly, as you might notice, I'm currently in a different venue from my living room or deck. In this case, I'm in my wonderful heated shed, which my parents have most gracefully allowed me to store my typewriters in. Previously, you would have just had tires over here. Of course, I paid for this U-line shelving. So, I currently have about 115 machines, around 30 of which are still in the house. And yeah, those 30 ones, most of these cases are currently full. As for the empty ones, those machines would be in the house. Salter, Williams. These cases are full. Parts machines. So probably by the time I've reached 150 machines, or at least acquired the majority of the items on my wish list, I'll finally do a full tour of the collection. And also such once I've finally gotten another set of this shelving, but on wheels, so I can produce like different separation here, and such separation also helping to protect maybe any potential museum visitors from the gym aspects. So as for this example, I got this off of Spanish eBay from the same seller from which I got this lovely Urania No. 1. In this case, I was particularly attracted by the fact that this one had white key inserts. I've only seen one other example on the typewriter database with such, and this machine also has fractor shift key inserts, which is quite interesting. But otherwise, it was packed nicely, arrived safely, and though the key inserts were a bit more cream than white, like they appeared in the photos, the whole machine is in just wonderful condition. Beautiful mechanical state. It was basically not perfectly functional. I only had to adjust something with the ribbon advanced mechanism. As you can see, all I had to do was just apply some purified water with some mild detergent, and with that I was able to bring out largely the original gloss. I'll probably come back with it and make it even shinier. But yeah, you can see beautiful reflections and the gold leaf on these Urania decals. In this case, I did have to make the decision on whether or not I wanted to settle this one, which does not have the special side color selection dial. In this case, I advised that since there were actually photos online, which I'll show you later, of one particular fellow's machine, where they took good photos of the actual color selection mechanism, and hence the differences, I would then be able to, upon acquiring this machine, show you guys the difference between the no color selector and the color selector models. For the serial number, you can find it right over here. And again, for this machine, this happens to be dated to 1936. Now, for delving into the mechanics, we will want to remove this beautiful top plate. The main other machine that has a similar top plate is a NEA, a 3-bank typewriter. I have yet to find one in good condition for a good price. In this case, you can remove that top plate via these screws here. And those screws also have these like felt washers. Now, when I get these machines all nice and clean like this, I of course want to use cotton gloves while handling them, since I don't want to get my finger oils on the wonderful paint. So mechanically, what makes this machine interesting is the type action. So again, as you would have seen in this video, and probably the revision of it, the type action is what is responsible for conveying motion from the keys to the type bars, which ultimately strike characters onto your page. So in this case, compared to the more common type action that you would see on portables like the Olympia here, where basically you have what's called a class 2 lever. So basically effort here, pivot here, load over here. That load pulls down on what are called bell cranks, and basically that pulls down, rotates this bell crank backwards, which then pulls on a link, which pulls on the type bar. So basically, many different typewriters use a very similar scheme for that type action. In fact, it actually, I believe, one of the earliest iterations of that would be the Remington number 10, at least the earlier ones, which I can now show you. So here you can see class 2 levers. In this case, now our bell cranks are much further up, but it's the exact same principle. So this machine here dates back to like the early 1900s. So yeah, exact same bell crank principle, and yeah, many different portable typewriters were produced with that exact same style, merely changing the shape and geometry and location of the bell cranks and their respective pivots and their angles. On the other hand, this typewriter uses a rather unique approach where instead we have class 1 levers. So your effort, your fulcrum, and then further down here is your load. So given that, it looks like this now. So basically, key lever pivots over back there, and this goes down, and then turns into this end. So that's in class 1 lever or bell crank configuration. Then that link instead pulls up instead of down, pulling on this bell crank. So the front part, in this case, moves the ribbon actuation bail, while this part here, or rather the upper part, is what is finally our bell crank neck, which then pulls on the back or the heel of the type bars. So a very unique type action. Now let's proceed to showing you my simulation of such. Another thing to notice is how these bell cranks seem to have been designed so that the distance from this front ribbon actuating bit and the ribbon actuation bail is further as you go toward the flanks of the machine. And I'm suspecting then that is probably because maybe basically with the geometry, these outer bell cranks probably move further. So like if that's my reference, okay, maybe. Kind of hard to tell, but yeah, basically imagine that you need, in order to get this bar to move by the same amount each time, when these guys are moving further compared to the innermost bell cranks, then you have to have them start further away. And I'm guessing that these pieces here were designed to be machined out of the same die, And then, because these are thin, these can be easily bent and adjusted accordingly. And likewise, you'll notice that these bell cranks have multiple holes. And in this case, it so happens that the front long levers, since they're longer, then in order to have the same key travel for roughly the same bell crank motion, these links here, which at this end are connected all at the same spot, have to pull in the bell cranks from a smaller radius, whereas for the upper keys, which are shorter, they have to pull from a further radius in order to get roughly the same resulting displacement of the bell crank. And likewise, since in order to basically, as part of enabling a more even touch throughout the keyboard, here they had to have longer bell cranks on the outside to match the shape of the type basket. They also match these long bell cranks with the longer ends down here at the heel of the type bars. Okay, so here we have a simulation of that exact same type action. So, as you can see, it works just as it does in real life. Class 1 key lever, well, or bell crank, given these angles. And then that pulls up over here on this bell crank. It's approximately 90 degrees. That finally pulls on this link here. And then here we have my simulated behind segment universal bar. Doesn't really have that much of an effect on the simulation other than a small spike in the force curve. So again, you can see now to show the force curve. So for more about type actions and force curves, see this video over here. So the force curve will start on the right side, progressing toward the left. So that's the force on your finger, well, the net force, with respect to the y coordinate, or the vertical displacement of the simulated finger. So let's do that. You can see here, it progresses in an increasingly increasing fashion, like so. Starts here, then increases. Now, one interesting thing about this is that this is technically rather similar to the force curve of the Olympia SM4, at least to the best with which I have made this simulation. I mean, there might be various small geometric errors, but as far as I can tell, it's pretty accurate. Now, again, you'll see basically that exact same force curve with minor variations. Maybe just the shape and be slightly different. So yeah, rather interesting because I do find that this machine feels much lighter. So I'm guessing that yeah, the Urania does have basically the same increasing force, but vertically translated upwards by a fair bit. Lastly, for the angular velocity of this type bar here with respect to time, as with most of the other type actions that I've simulated, generally, regardless of the actual force curve, this type bar here actually accelerates by a constant rate, so quite linear. Then it returns. In this case, it still happens to basically maintain its same angular velocity during the return, though as I've eventually found, whether or not the angular velocity will decrease or increase or stay constant with respect to time does depend on the coefficient of this spring here for the key lever. So if I were to now do this, we still get basically constant force there, but now you can see that since the spring is stronger, we do in fact get an increase in the angular velocity. But yeah, in terms of like how this affects the actual typing speed or how easy it is to type fast on a machine, basically, though having stronger springs will allow your type bars to return faster, it will slow down the actual pressing of the key and will make it heavier. So while some people may believe that stronger return springs or return forces will make for faster typing, really it's heavier typing, while ideally you actually want as light of a touch as possible in order to basically allow you to press a key as quickly enough and release it as quickly as possible, and then be able to move your fingers quickly to the next key. Now that we have discussed the unique type action of this machine, let us proceed to look into the implementation of the other mechanisms. So first, let's look at the ribbon actuation mechanisms. So basically, whenever you press a key, that will push on this ribbon actuation bail. So that bail pushes on these links, which further back here push on these class 1 levers, which I'll show you later, or what actuate the ribbon. But first, let's look at this guy here. This wire link, which is connected to the elbow, gets pushed, and that in turn rotates this class 1 lever on the side, which then rotates this bell crank, and you might eventually see that there's this class 1 ribbon vibrator lever that finally gets pushed and then lifts the ribbon vibrator, like so. So that's the ribbon vibrator mechanism. Here you can see that the ribbon vibrator additionally has this slot to help support it and keep it upright. Okay, so to show you the version of the Klein-Urania that has a color selector, I'm going to go ahead onto the typewriter database to mooch some photos from this guy. So if you don't like me sharing your photos, let me know. But yeah, it's always nice when collectors on the typewriter database share good and detailed photos of their machines, which definitely help others with their research. But yeah, the important bit is down here. So now to show you where this link comes from, I'm going to take this photo from an eBay listing. I mean, it's not going to be public once that listing eventually expires and gets deleted, but yeah, this is the best photo that I could find so far. But yeah, basically compare that to my machine. Exact same thing, bell cranks. This bail here pushes down on, well, up on this link, rotating these class 1 levers, which I will have shown you actuate the ribbon advance mechanism. Exact same principle as on here, as you can see. Same levers, but the difference is, instead of this lever pushing on a point to which is connected this wire link that then engages a class 1 bell crank. So class 1 bell crank here, rotating this guy. Now, on this machine, it instead pulls this V link toward the back of the machine. So you can see that V link right over here. This guy moves, this guy gets pushed toward the back of the machine, this guy gets pulled. At the end of that link is a pin, and that pin engages this slotted lever. Now, the position of this pin with respect to this slotted lever is set via this link to this other lever here, and that lever is connected to your color select dial. So, if you rotate this all the way counterclockwise, that will rotate this lever all the way down, such that this pin will end up over here, interfacing with a slot, such that when this V link gets pulled toward the back of the machine, this lever will not rotate. But if you rotate this then clockwise by 1 click, so you can see here there's a detent for your 3 positions, that will cause this pin to interface at a larger radius. That means that for the same displacement of motion of this link, this end here will pull this wire by a smaller amount. But if we then rotate this one more time to get to the red setting, that will finally move this pin here all the way up to engage at the smallest possible radius, rotating this wire by the greater amount, and that will then lift the ribbon vibrator high enough in order to reach the red or lower part of the ribbon. Given that, we finally have the analog of the wire link over here being instead manifested over here, where it interacts with a class 3 lever, so fulcrum, effort, load, instead of a class 1 lever, like over here, where instead we have the order of effort, fulcrum, load. But otherwise, that tip over here interacts with the exact same mechanism, the same bell crank that pushes on this lever, which basically lifts your ribbon vibrator. Exact same principle. Okay, so to make these differences easier to understand, I've made rough simulations of these ribbon vibrator mechanisms and overlaid them over the type action simulation. So in gray over here, we have the parts that are common between both versions. So that is our bail. Then we have this link, which goes up to this class 1 lever that performs the ribbon advance mechanism. So let's say that we're starting in stencil mode, meaning that the ribbon vibrator will not lift. Then you can see in black here we have the mechanism on my machine, which does not have a color select. So I'm using this dark gray over here as a reference just to show how much displacement we have. So that's that wire link that pushes this bell crank. Now the actual carriage itself is like at a slant, so that pushes that other bell crank this guy, that's what we're pushing. And here I'm just using some constraints and springs to simulate the weight or resistance of the ribbon vibrator that resets this mechanism. Then over here you can see, at least I believe, this link over here as well as this slot is shaped to ensure that with this pulling action in the color selection version, this pin will not be able to interact with this lever, thus preventing the ribbon vibrator from being lifted. As you can see, this part remains stationary. But when we switch to black mode, like so this is my simulated detent, now we have moved this pin up into a position where it does engage. And now this link starts pulling. Now, of course, this won't be perfectly to scale compared to the photos, but it works reasonably, and as you can see, I've tuned it so that we will end up with basically the same displacement of these pushers acting on that lever. That means that both of these mechanisms will be equivalent in lifting the ribbon vibrator to put the black part, or the upper part of the ribbon, in front of the slug that is actually contacting the page. And finally, when we flip the dial all the way clockwise, well, from the other side of the machine, this pin will be at its highest point, or the lowest radius, causing the greatest amount of displacement up here. And as you can see, now we've basically doubled the displacement of this class 3 lever compared to this class 1 lever, allowing us to lift the ribbon vibrator enough to access the lower or red part of the ribbon. Now let's see how the presence of this ribbon actuation mechanism, well, both of them, influences the force curve. So as you can see, get a bit of, but yeah, overall it's still the exact same shape, pretty much. Now, I guess, well, yeah, so you'll also notice that if you are still stuck in that position and you try to move the dial, it will get stuck. But if you are already fully reset like so. Now let me speed this up. There we go. Then, let's say you're already stuck in the pressed position, or yeah, let's say here, this position. So you're over here. Let's fix this down. You will in fact be able to switch between your different color settings while the key is still pressed down. Yeah, it depends on the particular color selection mechanism of your machine, whether or not you'll be able to do this. And then if you do that, then you'll get stuck in the stencil mode until you release the key. But yeah, overall the general idea is that this here will not really alter the shape of your force curve that much, though it will still make your keyboard feel a bit heavier due to the presence of that force from this ribbon actuation bail. So again, that color selector would have filled in this empty space. Now we can look at the ribbon advance mechanism. So again, you press the keys and they move these class 1 levers on either side. Now, removing these, in this case it's held with ball detent spools, we can see that that class 1 lever interfaces with a slot in this slider. So, press a key, it moves this slider forward and backward. So then you'll see that we have our stop pawl and go pawl. So when you press a key, the go pawl advances the spool ratchet until the stop pawl is able to click, allowing the go pawl to reset and then click in order to engage the next tooth. And as you can see on this side, this side here, the opposite spool is not engaged. In that case, that's because there are pins here that are preventing it from moving or from being engaged, basically pushing it away from the spool ratchet. Now, as for the automatic ribbon reverse and how we switch from winding one spool to winding the other once one of them gets emptied, basically, as you have the spool here and it gets fully pulled, there will be tension that will pull this sense lever in this direction. Now this sense lever, its pivot is over here, and it is a class 2 lever which has a pin down here, and that pin interfaces with this class 1 rocker that contains upward facing pins that push away the stop and go pawls. So if you start off from a state where these stop and go pawls for this side are disengaged, then when the automatic ribbon reverse engages, that will flip that class 1 rocker, as you can see, and in turn move our pawls into engagement. As you can see, thanks to this being class 2 and the actual rocker lever being class 1, then this being pulled in this direction actually causes this point here to be pulled in the opposite direction, in turn, by this cross-link pulling the opposite rocker, and hence disengaging its stop and go pawls. So that's your automatic ribbon reverse. Now, when I first received this machine, there was an issue with the ribbon advance not really working reliably. Basically, when I pressed a key, this part would move, but it wouldn't move far enough, and hence, unless you really pressed hard, or like fully, then the ratchet wouldn't actually be able to advance by a tooth. So that was annoying and basically caused me to constantly type on the same part of the ribbon most of the time. Now, the first thing I tried for adjusting that was basically, originally there were these probably original factory bends, just small bends in these links, which would have technically caused the distance between their ends to be shorter. So unfortunately, I undid those bends. Then, since that wasn't enough, or it would kind of work and allow for advancing of the ribbon, but at the expense of you not being able to do so very fast. So I then found out that you actually have to instead loosen these screws here. So this screw secures the shaft at the base of this plate here, and then you have to loosen this screw, which allows you to also likewise fix the angle of this piece. So basically, when you loosen those screws, you'll be able to rotate this entire assembly and in turn position this slider with respect to the resting position of that Class 1 actuation lever. And with that, you'll be able to adjust your stop and go pawls so that it will be able to click at a reasonably short distance and reliably reset when you release the key. Now, another thing that I noticed is that during the automatic ribbon reverse, there will be a torque applied to your spools. In this case, a torque in this direction. So make sure that you adjust this advancement to be able to function while there is a torque being applied. Otherwise, you'll find that initially it will be able to nice and responsively and early on advance the ribbon. Like for example, maybe you'll be able to get this stop dog to click right at this point, nice and early, meaning that you can type very fast and still have the ribbon moving. But once you start getting a torque in this direction during the automatic ribbon reverse, where there's tension originating from here, you will find that all of a sudden the ribbon advance will stop working. So given that basically fixed things, though now I technically have one remaining issue where I reach a point where this mechanism technically works, but the rocker gets stuck in a middle position where both of these pawls are engaged at once and conflicting with each other, and the tension is pulling both of these sense levers toward one another. So for that, I suspect that maybe this machine was actually designed to use something like a ribbon eyelet to help isolate the tension so that it will only pull one of these at a time, instead of having the tension pull both of these sense levers inward. Next, let us look at the backspace mechanism. So basically, you have a Class 2 lever. Oopsies. So you can see, pivot over there, then pulls down on that link. That in turn pulls on this bell crank, which then pushes that link over there, which rotates that other bell crank. You can see over here. That bell crank finally pushes on this sliding piece, the end of which has a pivoted backspacing pawl that pushes on the carriage rack pinion. So the carriage rack pinion is what the carriage rack engages with. So I guess by some interesting design decision, they decided that they would have an intermediate pinion before that pinion engages with the actual escapement pinion. So that here's the escapement and the escape wheel down there. So, I mean, number one, they would need that if they specifically wanted to have the backspace on this side and pushing from this direction, or if they weren't able to like change the direction of spin of this escape wheel. But yeah, this is what they came up with. Now we can see the escapement here. So basically, firstly, Spacebar is implemented with this L-shaped piece here. That's the pivot. Then you have this wire link, which pushes down on this piece here, engaging the parallel linkage of the behind segment universal bar assembly. So the U-bar, well, the original universal bars were straight, like this guy. Then they invented the behind segment universal bar, as they call it, which was actually U-shaped. So, yeah, basically, in this case, this connection point here is made as a loop so that when you press a key in order to engage it, doing so will not additionally cause the spacebar to be depressed. And likewise, you'll be able to isolate the inertia of this whole mechanism from the inertia of the spacebar, allowing your regular typing escapement actuations to be faster. Anyways, so basically, as you can see over here, there's an edge, and that edge is what contacts that behind segment universal bar, and finally pushes this whole assembly toward the back of the machine. That, in turn, pushes on this lever, rocking our escapement, whose pivot is over here. So this here is our stationary dog. I suspect that he might be able to adjust it, else these screws might be single fixed position for your stationary dog, and then you have your floating dog. Floating in the sense that it is able to move back and forth for some mechanically advantageous purposes. Now for the carriage turn, this is implemented with a ratchet integrated into the escape wheel. A similar approach is used on the earlier Royal standard typewriters, maybe even also on later ones. Yeah, these early machines didn't really have what's called a silent carriage return that removes that clicking that you hear. But on this machine, because it uses a crown clutch like so, or in this case just that small ratchet, you only get a very, very quiet rattling here. And at the same time, our floating dog moves to the fully engaged position until it's stopped. In this case, we have this little small spring here, which I guess adds a bit of a padding. And once that's stopped, the ratchet is able to act. Given that, we then have the carriage release lever here. So, yeah, this machine we only have it on one end. Now, a number of machines, they opt for having a carriage release lever or button that directly moves this carriage rack or gear out of the way of the escapement pinion, or in the case of those which don't use a rotational escapement, namely called a linear escapement. For example, the Erica typewriters use such. They're simply moving the rack out of the way of the escapement dogs. The dogs being, yeah, those points there that are interacting either with the escapement teeth or directly with the carriage rack teeth. In this case, this machine, a number of different machines use a similar approach. I believe Olympias also do this. They instead have a bail here. Basically, I think as far as I know, the reason it's called bail is because it's like a bail handle, shaped like that, with pivots here, and then you have a long part. So that's a bail or bar. That rotates. That in turn pushes on that lever over there. And then that lever, finally, via that surface, pushes the, oops, that's a belt trip, the escapement pinion out of the way of this crown clutch. So now it's engaged, now it's disengaged. Now you're able to smoothly move the carriage back and forth. Now for escapement trip adjustment, in the case where you want to, let's say, improve the performance of your typewriter, so typically you want your escapement trip to be reasonably late while still being reliable enough. So like if it will only trip when you press really hard, then you might find a lot of cases where you're able to type fast, but if you don't press hard enough, then it's going to fail to register your key press. So in order to adjust that, what I suspect, so yeah, my machine, as you can tell, is probably already in good condition, or adjustment, and I suspect that that little pin here is on an eccentric disc, and when you loosen this nut, you'll be able to rotate that screw there in order to rotate this eccentric, hence setting it to push on this arm here, either earlier or later. And do note that when you make that adjustment, you might also have to make a corresponding adjustment to ensure that your spacebar trip is still in good shape, not too early or too late. Then, as you approach the end of the line, we have the belt trip. So we simply have this piece here on the right margin with the slanted surface that advances, then it hits that tab over there, pushes it until it trips. In this case, you just have this whole big bell striker and this straight wire spring that also helps to serve and keep the sufficient clearance for allowing a nice rebound and a nice and pure tone, as you can hear. That's nice. And then on the carriage return, that belt trip tab there will be able to move out of the way in one direction, nice and quietly, to allow for a carriage return without causing any motion to the bell striker. Anyways, going back, finally, once you reach the end of your line, or basically reaching your right margin, that slanted tab will reach that guy there. That will engage your line lock, which will prevent you from typing further past your right margin unless you explicitly engage the margin release over here. So the way that worked was we have this class 1 lever here. So that slanted surface is pushing on that class 1 lever, which with this wire link pushes on, I'd call this a class 3 hook, insofar as technically our load is that hook end, which finally blocks motion there of this universal bar assembly. And then when we engage the margin release at the back here. That will put it out of the way and allow us to continue typing until the second tab over there, which is on the same protrusion to which the drawband is mounted, engages the absolute right margin and the associated line lock, which you cannot surpass. And here we have that same mechanism from behind. So yeah, you can set these margins for setting the left and right margins of your page just by pinching and sliding. So in this case, that will hit your left margin, and your margin release will simply rotate your margin bail out of the way. Again, carriage release. You don't have to pinch this at the same time. So now, bell trip. That's your line lock. And then our margin release. Continue typing. And then you're back at the very end of the line. And you can't do anything about it but just simply do a carriage return. In this case, this machine, interestingly, uses a right-hand carriage return. Unlike many of these typewriters, I mean, I guess quite a few German typewriters use right-hand carriage returns in the same fashion as the original Remingtons, like so. In this case, mechanically, firstly, we have this guy that allows it to be stowed down while being stored in the carrying case. So, yeah, you pull it with your thumb, and then we have a pawl down here that does the engagement of the platen ratchet, and this here is our line finder, which for the most part reveals a pretty nice and smooth platen. And you may also notice that this platen here, you can still see the original helical grinding marks from, I guess, when they get machined and trued the roundness and dimensions of this platen. Though I did find that one side or diameter, maybe from age, else from tolerances, was a bit bigger than the other, but the machine still types. Now, unlike most other typewriters, this particular example does not have a line spacing control that allows you to switch between single, double, or maybe even triple spacing. And I'm not sure if the models that did have a color selector had some sort of line spacing selection mechanism. We then have the paper release mechanism that allows you to basically remove or readjust your page. In this case, it so happens to be the exact same style, generally, as on my Urania No. 1. At least the lever here. On this machine, basically, like on many others, just uses a rotating shaft, and you have that slotted part there. When you engage it, it pushes on this piece here, which pivots the feed rollers away from the platen, allowing you to more easily remove your page midway or readjust it. As you can see here again, the Urania No. 1 has a very similar paper release mechanism. Then, if you are finding that the resistance on your otherwise smooth carriage is too high or too low, like either you're typing and the carriage isn't really moving fast enough, or you're doing a carriage return and it's too stiff, then to adjust that, you simply need to go over here. You may or may not have to loosen the screw in order to allow this rocker to act, but if you're familiar with clocks, this rocker is basically the same thing as an escapement pallet and acts to allow you to safely, one tooth at a time, loosen the mainspring, or in the case of you're tightening it, once you let go, it will automatically lock and protect it from a rapid unwinding which could damage or snap your mainspring. Lastly, we have the shift mechanism. In this case, on this machine, the carriage shift actually happens to be pretty nice and light. It does have an assist spring, which you'll see. Otherwise, it just feels nice and balanced and has a bit of a tactility to it. Just nice and smooth. This one's a bit heavier. Yeah, I definitely like the operation of this carriage shift. So, you can see over here those links. So, class 1 shift lever. Do note that for your shift lock, that's just implemented with this lever, goes down here, then you see that ledge there, that will get stuck on that surface there. And then when you press it down, it will disengage. So now going back to the underside of the machine, a bit harder to really, okay, yeah, I can do this. So, yeah, just the basic parallel linkage. Maybe there is a different term for this kind of linkage, but... And then if you want to adjust your shift alignment, you can do so with these nuts and screws. In this case, this Urania is already in pretty good adjustment. One thing to note is that when putting the top plate back on, you'll want to make sure that you can get this piece here to clear right behind this front plate, and you might have to remove the spools first to enable that. So like that, push it in, and then you're good. Then you can put the side screws back on. Okay, so now that we've gone over all the mechanics, we can now type. Now, in terms of your margin setting, do note that for the left margin, you have to align the left side with the tick that you want. So if I want my margin to be at the 10 mark, then the 10 has to be on this side of the left margin. And for the right margin, same thing. We have to use the left side as the reference. So make sure your paper release is in the release position. So you can do that by just pushing it toward the back over here till it clicks. And for smoother line feeding, you can pull this forward to get the line finder. Basically disengaging your platen ratchet, click. Let's see, there you go. It's nice. That's your paper bail. And if you want, you can readjust like so by pulling the paper release forward. That should be good enough. Push that back, and we're ready to type. And the time is 11:38 p.m. Of course, this particular right-hand return lever makes it a bit harder to carriage flick or quickly do a carriage return on your typewriter, but otherwise, the rest of this machine redeems it. Just feels quite wonderful to type on. It's a wonderful, lovely machine with a lovely, full, solid touch. Now, again, as you would have seen from the simulation, apparently the force curve is supposed to be similar to my Olympia SM4, though that machine is substantially lighter in touch. So I'm guessing that maybe it is in fact roughly the same, like, shape force profile, but like vertically translated upwards. But yeah, this machine is pretty darn fast. Now, when I first received it, and let's say that, yeah, I'm not supposed to use chemicals indoors, or at least not in the house, so eventually I was finally able to move to the shed, but before that I hadn't applied my trusty liquid wrench solvent and lubricant. And with that, this machine was feeling a bit more sluggish, and the type bars weren't returning as fast, and so I found it a lot harder to type quickly without encountering type bar collisions. But now that I've used all my liquid wrench to basically dissolve any gunk and also just smoothen all the pivots, this machine now types wonderfully. Oops. Yeah, basically just about as performant as any other typewriter, or portable typewriter at least. But yeah, with a bit of touch on the heavier side, but still quite pleasant. Oops. Yeah, type and shift alignment are pretty reasonable, except for this 2 key, where as you can see, the slug is somehow too low compared to all the other slugs. Like, all the other top row slugs are in reasonable alignment. Yeah. I mean, if you look at the 2 key, it doesn't look like I can really do any bends to fix that. So the only solution might be to resolder that slug into proper alignment. Anyways, let's do a bit more typing. Yeah, so an absolutely wonderful typewriter, and I guess on closing thoughts, 2 main machines that I would compare the touch to would be the solidness of the Continental standard, as well as the fullness of the later, at least starting with the number 5, I believe this one's the number 6 Express, Mercedes typewriters. So yeah, consider that. So once you finish typing, you can just pull the paper release there and pull your paper out. Alright, so that's it for the wonderful Klein-Urania typewriter. If you found this video interesting and would like to learn more about typewriters and their workings, feel free to like and subscribe.